Okay, so we're asked to find all real solutions to, firstly, 16a squared equals 2 root a. So what I'm going to do is first divide each side by 2 since they're both divisible by 2. So we're going to get 8a squared is equal to square root of a. Now it looks like we're going to have to square it to get rid of the square root because otherwise it's just a bit more complicated to work with. If we square both sides, we get 8a squared is equal to a, which means 64a to the power of 4 is equal to a. Now what I'm going to do is bring the a to the other side to make it equal to 0. So 64a to the power of 4 minus a is equal to 0. Factor out the a's, so we get 64a times 64a cubed minus 1 is equal to 0. It's important that even though we don't divide by a, just because if we divide by a, we lose this solution where a is equal to 0. So our solutions are a is equal to 0, and then the other one is when 64, I'm just going to do it over here, 60, so 64a cubed minus 1 could also equal 0. 64a cubed is equal to 1. So a cubed is equal to 1 over 64. So a is equal to the cube root of 1 over 64, which is just 1 over 4. So there are our solutions, a equals 0 and a equals 1 over 4. So now on to part b. B to the power of 4 plus 7b squared minus 18 is equal to 0. So when we have powers of b that go in like a alternating fashion, it's important to recognize that we can just replace it with another term to make it quadratic that it's easier to solve. So in this case, let's let b squared equal u. So that becomes u to the power of 2, sorry. It becomes u squared because u is equal to b squared, and b squared is b to the power of 4, plus 7u minus 18 is equal to 0. And now it's an easy quadratic to solve. It gives us u plus 9 times u minus 2 is equal to 0. So u is equal to negative 9 and 2. But we're not done yet. We need to substitute b squared back in. So b squared is equal to negative 9, and b squared is equal to 2. So from the second one, we already know that b is equal to plus minus root 2. For this one over here, we know that b is equal to I root 3. However, it did say plus minus I root 3. However, it did say that it should only have real solutions. So therefore, this one here is invalid. And this is our solution, our real solutions to the problem. So therefore, a equals 0 and a equals 1 over 4 for the first problem, and b equals plus minus root 2 for the second.